Good evening. Now we are going to introduce the last speaker of the day. We are going to speak about the optical solution for industrial application of coherent electro-optical components. It's a part of the larger group Coherent. It's really a pleasure. I have not to spend too much words to say what is Coherent. We are a little late, so go straight to the presentation. Thank you so much.
Yes, thank you. Hello, everyone. Just for a little background, we were acquired by Coherent about 2 months ago. We were formerly Electro-Optics Technology, which I hope is a recognized name in the industry. We've been around for about 30 years or so, making optical isolators, photodetectors, and fiber delivery solutions. So I'm going to talk about how EOC, formerly Electro-Optics Technology, can work with the industrial community and partners on components that hopefully enable you to take your products to where you want to take them. I'm going to stay away from staying into products and just talk about how we've collaborated with people over the years, some examples of what we've done to get us to where we are, and some of the areas that we're looking at in the market and some of the products we're going to be looking at in the future. So with that, just a couple of introductory comments. We have a unique ability here, we think, to handle fiber handling, termination, and also large bulk optic design. So we come at it from both angles. We can handle fiber optic delivery, and we can connectorize that into bulk optic designs. And I'll show you some examples of that. We also have a bit of vertical integration. With our company being sold to Coherent, along came with it crystal growth capability in Germany. Formerly FEE is now part of Coherent as Advanced Crystal Group Germany. And with that, we use all of our Faraday materials in our optical isolators that are grown internally. And we do our own optical coatings for these, and we also sell these on the market. And there's some good industrial solutions on the crystal side that I'll talk about on my last slide. But we have an internal in-house engineering design team where we can take your design, your concept, and bring it all the way through prototype and into production. The areas that we like to focus on that I have down here are high power applications. We like to stay on the cutting edge of high power, high brightness preserving. Mostly that's in response to fiber and fiber connectorization. Low swap, so size, weight, price. These are all things that we're focused on in terms of size of product. We like to value high isolation, high transmission performance. And if you're talking in fibers, low insertion loss, high damage thresholds, and we have a very strong ability to make large aperture Faraday isolators and optical isolators for the laser community. I'm not going to touch on this very quickly, but we're in Traverse City, Michigan. We have 2 facilities where we do our manufacturing, and we have another facility that we do optical coating and some fabrication. We're in Traverse City, Michigan. I touched on some of the capabilities. So we have a strong product development engineering team that we like to collaborate with people on. We can do Zmax, COMSOL, finite thermal modeling, SolidWorks design. So we like to hear from the laser engineers on what we can do to enable specs and capability in our products to deliver on a prototype and into production. We have some metrology on site as well, where we can do some environmental testing, some high power damage testing, absorption, spectrophotometers, a variety of equipment to help support our design team. Then if you'd like to, we can take you into manufacturing. We have ISO 5 and 6 clean rooms. We can do high volume flow lines. We can do small custom orders. We can do build to print. Like I mentioned, we have optical coatings. So we have IBS coatings where we do very low absorption, high damage threshold ARs and HRs on all of our components. We can do some optical assembly, wire bonding, And then we have an internal machine shop that has advanced skills in fixturing, prototyping, welding, 3D printing, or we can come up with other solutions to go into high volume. But we can respond to things very quickly. We're pretty nimble, and we like to value short lead times in our responsiveness. I'm just going to summarize the collaboration, and then we can get into some of the products and technologies that are available. But like I said, build to print, stock programs, support and design and prototype phase, high power environmental testing, high volume transfer if you want to go to a partner or one of our partners. We can build the complete components, coatings, fixturing, and modeling are our main collaborations that we do with laser engineers and all stakeholders that are interested. The markets that we participate in, I mean, this is largely the same markets that most of you are in, but we're participating across the board in terms of all major markets in the photonics industry. So here I just wanted to set a little perspective as to how we pretty much got ourselves into more of the industrial side of the market. We started more as a research institute or research component supplier, and really got into more industrial stuff in the early 2000s. A lot of that started as we were a large supplier, critical supplier into the National Ignition Facility, the NIF program with Lawrence Livermore. We supplied hundreds and hundreds of devices into this system. And as a result of that, some of the technology that spun out of this program resulted in some laser shock peening systems, where we would use our large aperture devices to support these larger system integrators. And these were used in a lot of ways to clean up jet turbine engines after usage. But that started kind of in the early 2000s and into the mid 2000s, where we provided large aperture devices into the laser shock peening industry. Also, the work that we did with Lawrence Livermore resulted in a CRADA, a joint public-private program that started in 2019, where we developed a 25 kilowatt isolator, which is shown here. You can see my mouse, which is actually gas purged, which is under kind of current testing as well. But this was an example of where this will eventually get into some industrial applications and high-speed metal 3D printing. So I'm just bringing up, I guess, how we've worked with research institutes like Lawrence Livermore Labs that eventually deliver product to the industry that's used in the industrial market. Our role there is primarily as a component supplier is large aperture Faraday devices. These have large pulse energy, and we have ways of doing the modeling and optical design to handle that. If we switch to the pulse fiber laser market, we had a pretty strong position there in the mid to late 2000s. We started at about 20 watts, providing a fiber pigtail device for Q-switch and MOPA type fiber lasers. And we have shipped over 35,000 of these into the field. A lot of price pressure and competition in this space forces us to continue to push the power thresholds. So we have since exited a lot of that market. We now work on we ship a 250 to 300 watt dual stage product, which is in this lower right corner. This device is kind of one of, at its time, first of its kind, where we offer extremely high isolation. We're using materials that have very low thermal lensing. So we're able to push the power levels through our device. And these are sold primarily into the dissimilar metal welding, cutting, and e-mobility market, which we still support. So that's kind of where we are with the fiber laser market. And then in the CW industrial laser market, we can design and have built these free space type products in the lower left corner, where you can also connectorize those with like an outside type product, like an optoscan collimator plugin. We also do free space products that can be used for multi-kilowatt beam splitting, And these are typically used in welding applications where there's a high back reflection possibility. And we've been supplying those since the early 2000s as well. So in terms of product coverage, I hope people can just get this slide deck. I'm not going to show a lot, but this basically just shows product types that we offer here for wavelength ranges and into solid state or quantum cascade or CO2 lasers. We have a product portfolio. We deal with the spectral bandwidth all the way from CO2 down into the low UV. So we cover the entire wavelength range with products and for different applications. So we can talk about that later. Some of the industrial components that we're working on right now and also have developed into the market, which have been pretty favorable. If I start on the free space side, we offer a free space product for the industrial market that is either TGG based as a Faraday material or KTF based, which is a terbium potassium fluoride crystal that can be used in our devices as well. We have a product line for both. Depending on your application and your power scaling needs, we can recommend a solution for you based on beam diameter and power thresholds and damage threshold levels. But in general, KTF has a better performance at higher powers in terms of thermal lensing and Rayleigh shifting. With TGG-based devices, and in most applications, after about 50 watts, you're going to start to notice some sort of lensing, which can be compensated. But we do have solutions for power scaling in industrial environment if you need. But we would look at different Faraday materials, different coating designs, different optical isolator components. But we can power scale into the multi-kilowatt range with our products. We also can do slab designs. If you have an elliptical beam, we can do different things so you don't have to do beam shaping. So we have a lot of design capability where we can customize products for you into what you need. If I switch into fiber coupled devices, like I mentioned earlier, we've kind of gone into the low swap arena. We have a variety of fiber components, fiber coupled components that are either PM or PI. They go up to 40 watts. We have some that are even lower power for 5 watts. These are good for in your amplifier stages. And we can handle lots of different fiber types and terminate these and handle them within our isolator packaging. So if you're looking at power scaling and amplifiers and need some isolators within those designs, we would like to talk to you and support you in those ways. So they don't really show up well on the presentation, but they're the size of about a Bic lighter and they're sub 40 grams. So these tuck away really nicely in a small form factor and very lightweight. We also have a program going on to power scale this up to 100 watts for fiber to fiber products. We have a nice ability to supply fiber termination, fiber deliveries. So we can do an optical mechanical type assembly here. The key things of technology here are that we have kind of a monolithic design, which is a sealed glass type architecture where we have very limited adhesive. And these can be used up into multi-kilowatt type environments. And if you need types of cabling or types of beam expansion onto these things, we have that in-house. We can do the coatings and fabrication of these optical components. If you need to get into different types of end capping or nanostructuring, we have services and things that we can do along this as well. So on the fiber side, our two main industrial components that we can support you on are fiber coupled devices and beam delivery, what we'll call collimators and terminators with end capping. And also, if you need some standalone type things for the industrial world, we have high extinction, high damage threshold, thin film polarizers, collimating lenses, and we can get very good at doing filters. We have real tight control on doing AES filters that either can be designed into the isolator itself or or separate bandpass type filtering, where we can control into just a few nanometers. This is just kind of an example of what I would show as an ultrafast layout. We don't make all of these components, but we are entertaining collaboration if needed for power scaling, which provides unique space for customers. So we are a component supplier that has capability of providing most, if not all, of these types of devices, and we'd like to talk to you if you need support in these areas in the ultrafast type architecture. My last slide, just talking about some of the crystals. So now these crystals are part of Coherent's portfolio. They are part of the Advanced Crystal Group in New Jersey, and they complement what Coherent has already been supplying for many years. But our crystals here that are shown are more oxide type crystals, terbium oxide materials. So we're talking YAG, different dopants of YAG materials, holmium, chromium, and neodymium. The things I would like to point out for the industrial community that I think we do well for customers is 2 and 3D structuring. So we do all the fabrication and polishing in-house. We can do some nanostructured surfaces with partners. We also get into structuring the barrels if we need to do heat dissipation on these to create more surface area on parts. We are very good at optical bonding and doing segmented crystals if you need to pump in different materials. We have high power coatings, and we can do custom doping levels within a given crystal type. So that's pretty unique in the industry. And we have a pretty advanced PhD team there that can support you if you need lasing crystals or also host crystals for pumping. At that time, that's what I wanted to kind of give to the community here today and provide what capability we're there. And there's some contact information for myself. I'm the business unit manager here in Traverse City, Michigan, and our sales director, and also a new product design engineer, Connor.
Okay, Ben. Thank you so much. It was really impressive presentation. I am a laser guy. I'm coming from laser field, so I have to ask so many questions for each of your slides. So I try to really to make easier because also we are at the end of the day. So yeah. I was impressed by 2 things. One is about the high power about isolators. So here I will ask you if you see any limits, any threshold of power that you can't pass. And the second one is I saw also interesting development for ultrafast laser, high power ultrafast. This is also something that I would like maybe a comment from your side.
Sure. Maybe I'll start with the ultrafast one. That's a little more straightforward for me to answer. In the ultrafast area, what we're seeing specifically in the femtosecond arena is an interest in our free space products that are KTF based. So these are what we're seeing in the industry is people pushing, above 50 watt pulse applications, and KTF with its very low thermal lensing and good thermal characteristics provide the opportunity for laser designers to not have to compensate for thermal lensing and push the power threshold. And what complements this product well from a crystal portfolio, we've seen interest in Calgo. Calgo is starting to get a little more traction to replace KYW as a host crystal for pumping.
Yeah, sorry Ben to interrupt you. Can you stop sharing so we can see each other larger? So
yes, of course.
Thank you so much. Great.
Is that good? Okay.
Yeah, perfect.
Yeah, so I guess the two products that I think would be interesting to the industrial community from an isolator perspective and ultrafast would be the KTF based free space 1 micron terbium bandwidth type product, and then a host crystal for pumping. People could maybe look at Calgo as an opportunity. We've seen there's a lot of literature and white papers that we've been posting on Calgo that are available on our sites, or you can send an email. But as people are pushing power levels in ultrafast, we're seeing, and we're positioning ourselves as a component supplier to deliver on those two in higher volume. Your first question about limits and power scaling, that's a hard one for me to answer. It depends a lot on application and laser design. We're working, I think, with Livermore on pushing those thresholds on their programs, but you have to get into aperture sizing, coating designs. Do we have to purge with gas? But we are working, I think our teams are on the most advanced type isolator and coating design and component levels that are there right now. And it's not just Livermore. We've supplied parts into the French megajoule projects and basically any high energy, high pulse systems that have been designed.
Yes, I had also a live facility in
Yeah,
Europe. Yeah, that is something that is really making me more than happy. I'm coming from that field with ultrafast laser, so it's really fantastic. So I think that we are really closing with the best possible solution this afternoon, this long day. And thank you so much, Ben. And thank you so much also for all the people behind this organization. It makes
I appreciate the invitation, and we'll follow up with everyone accordingly. So thank you for your time.
Thank you. And I really invite all the people to visit the exhibition, join also the Wonder Me rooms and talk each other. Have a nice evening. Bye.
Yeah.